All right, so this is the Unit 3 test. So again, not everybody taken it yet. So I got them back, but now everybody's taken it, so now you can see the answers. This is our Becca operation. So in this one, with our free response, it says Becca craves Oreos and is ingesting them for 39 minutes according to this equation, where B of t represents the number of cookies ingested, t is the time in minutes from 0 to 39. As Becca eats, she does not necessarily ingest an entire Oreo at once, because it's possible she only eats half at a time, or like puts 3 in her mouth at once and eats 3 at one time. That's possible, so we have to keep that in mind. So part A says, discuss the continuity of B of t over 0 to 39. So we want to focus on the continuity. So if we look at our equation here, we have a trig function and a square root function. So since B of t is a square root function, a radical function, multiplied by I guess we'll do the radical first, a trig function over 0 to 39, it is always continuous. Well, I guess we would say, yeah, we could say always continuous. Because cosine is everywhere continuous. So from negative infinity to infinity, cosine's always got a value. And radical t, so square roots. So square roots are continuous from 0 to infinity. Because again, we can't put negatives in a square root. 0 would be okay to put in that square root, but so since it's always continuous on these two intervals, the whole thing has to be continuous because we're just multiplying two continuous functions together. So that's what we got for that. Most people did pretty decent with one of the two, so they kind of figured out, okay, I have to look at what these functions are. But you have to also mention that you're just multiplying two functions that you know are continuous. So that's what we got for part A. For part B, it says find the derivative of b. So we got kind of a big equation. It needs more space to just kind of write this down. So b of t equals 4 cosine 1/8. 4 cosine 1 over 8 pi, not 18. T, and then times radical t. All right, so I'm gonna make that time sign very obvious because that kind of gives me a hint that I'm gonna have to do a product rule. So my two pieces for the product rule are pretty clear. I've got this one, and then I've got this one. I could not include the 4. I could just have the 4 kind of out front, but I'm just going to keep it with the cosine 1 over 8 pi t. All right, so we see we got to do the product rule. So we're just going to run through the product rule. So that's the first times the derivative of the second. So derivative of the second is 1 over 2 radical t. Again, radical t is t to the negative 1, or t to the 1/2. If we take our derivative, that's going to become 1/2 t to the negative 1/2, which is then just 1 over 2 radical t. Can I grab that? Yep. All right. So that's the first times the derivative of the second plus the second times the derivative of the first. So the derivative of the first, we have this function. So we've got 4. Derivative of cosine is sine. So we're doing sine of 1 over 8 pi t. But we have a chain rule here because we're doing cosine of 1/8, 1 over 8 pi t. So I need to take the derivative of this. The derivative of that is 1 over 8 pi. Again, this is kind of just a regular power rule. In this case, it's t to the first power, so 1, just multiply by 1, and then the t will go away. That's actually it. We did it. Find b prime of t. We should label it as b prime of t, just to make sure. And we're all set. We got them all. So where do all the points come from? So point number 1 comes from just doing the product rule. So if you've shown the product rule, that's good. Point number 2 is from the chain rule. So again, that's the part in green here. Point number 3, you got for this 1 over 2 radical t thing. So if you did the square root of t derivative correctly, that's kind of number 3. And then point number 4 is the trig derivative. So if you showed that you could do cosine to, not sine, you gotta be careful. Negative sine. Almost messed that up. Derivative of cosine is negative sine, so about negative 4. So that would be where our 4th point comes from. So that's what we got. So some people, you gotta watch out. Some people lost points because they didn't have like a times here, and they just wrote square root of t minus 4 sine. That literally means square root of t minus 4 sine. That's not correct. So you have to make sure that you are being very precise with where all your symbols are. Again, if I want to be a little bit more precise, maybe instead of putting that negative sign right there, I could have put this all in parentheses or put the negative sign out front or did a -1 over here or something, but that's what I've got for this one. Again, my time sign is very clear there that I'm multiplying by -4. I'm not subtracting 4 sine. And that's part B. So then part C, it says Leah joins in the feast and ingests Oreos according to L of t. Okay, L for Leah. Equals heart t to the third plus 0.1 t squared plus 0.1 t over 0 to 39. If L parentheses 3 of t is equal to negative 0.012, find the value of heart. Okay, so our L of t function is heart t cubed and plus 0.1 t squared and then plus 0.1 t. So that's our L of t. All right, so we have to find L3 of t. So the derivative is the derivative. So this is going to be heart 3t squared plus 0.02t plus 0.1. Then our second derivative is 6 heart t plus 0.2, and that's going to become 0. And then our third derivative, L3 of t, is just going to become 6 heart. So that's kind of what we got. Now we're told that the third derivative is negative 0.012. 0.012. So that's equal to 6 heart. So we just want to divide both sides by 6. And that tells us that heart is equal to negative 0.012 over 6, or 12 divided by 6 is 2. So there we go. So that's what we got for that. So for this one was worth 3 points. So 3 points were first to understand that we have to do 3 derivatives. So point number 1 comes from just taking the third derivative. So attempting to do 3 derivatives is the first point. The second point is you need the correct third derivative. So point number 2 is we need to get to here. And then point number 3 comes from our final answer. So point number 3, if you got to there, that's where the third point comes from. So that's how to get all 3 points on that question. So that's that one. Pretty cool. So when you get the test back, you might want to graph these functions just because they're fun. They're fun to look at, the graphs. Always fun to see what that is and interpret what that actually means, but I'll let you do that when you get the test back. All right, for multiple choice. Question 1, Becca lives life without limits. Which graph is defined for all x values? So this one has 2 open dots there, so that is not defined. This is defined, that looks pretty good. That has the solid dot, that's defined. This has an asymptote, so that's not defined. That's defined, so that's good. But has an undefined limit. All right, so we want a limit that's undefined. Well, here we have our limit that is defined. Our limit equals 0. So the limit as x approaches 0 of our function is 0. That's the only point that looks kind of suspicious. Everything else looks pretty normal. We just have like a line and another line. Here we have a line that matches with a parabola, so I'd say that point looks suspicious, but that's okay. Looks like those are both also headed towards 0. The limit as x approaches -2 of our function is 0, so that's fine. Here is a piecewise function, so again, the suspicious point is where these two things connect, and they don't connect, so that's kind of weird. So the limit as x approaches 2 from the left of f of x is actually not equal to the limit as x approaches, not 2, -2, as x approaches -2 from the right of f of x, because from the left we're headed towards 0, and then from the right we're headed towards 1, 2, 3, 4, -4. So those two numbers don't agree. We could also say that the function value, f of -2, is also equal to 1, which isn't either of these values either. So that one has the undefined limit. So that's why we picked D for that one. If you picked either A or C, those have undefined limits for the derivative, not for the actual function. All right, 2, here's Becca's favorite inverse trig function. She told me it's arc cosine of t, so we have to find b prime of t, so we just picked the right one for arc cotangent. So arc cotangent is the same thing as arc tangent, which is the one with the plus sign, but it's negative because it's cotangent. So that's what we got for that one. 3, we have the Galactic Federation softball exhibition match. She's going to analyze one of her hits with Nika and Emma as they model the ball's path with the equation s of t equals -20t squared plus 75t plus 1. With time t in seconds, heights s of t in meters. We need to find the acceleration due to gravity for her match. So to get acceleration, we need to take the second derivative. So s prime of t is the velocity. So that's going to be -40t plus 75. Our second derivative is the acceleration. So if we take that derivative, we're going to get -40. So in this case, our answer is -40. So again, remember, Earth is like -10, so gravity is like 10 times as much on this alien planet. So hopefully she hit a good one and was able to overcome gravity. You'll have to check it out. Again, you'll have to actually make the graph to see. For 4, Abby knows Becca wants a chain for her birthday. She's leery of some items that look like chains but aren't when analyzed. Given the 3 options for presents, which one must use the chain rule to find the derivative? So what we're trying to do is we're trying to simplify these so we don't have to use the chain rule. And for the first one, this is just a binomial. So if we wanted to, we could actually just multiply this out to get 9x squared minus 30x plus 25. And then we could just use the power rule from there. So the G is not correct. L, we have a cosine and something in a cosine. There's no way we're going to get this thing out of the cosine. So we're good to go. Same deal up here. We can't really get this 6x out of this E. So we're kind of good to go there also. So we're going to want to pick 2 and 3. We can't really simplify these two at all to not use the chain rule. We would have to use the chain rule. If you didn't think you had to use 2, if you were just like, well, it's clearly just going to be negative sine 18x times 18, that's because you used the chain rule in your head. You did a great job. But it is 2 and 3. All right, for 5, Peyton's tracking Becca's nemesis so they do not ruin the day by stealing today's fun calculus experience. Peyton knows Becca is thinking f of x equals 5x cubed minus 18x plus 4, and Becca's nemesis is thinking the inverse. Peyton finds the following points on f of x, so she kind of knows either she plugged them in or she talked to Becca. Find f inverse prime of 8 to help Peyton predict where Becca's nemesis will be. So we're using the inverse formula. So f prime inverse of x is equal to 1 over f prime at f inverse of x. Remember, in this case, if you're used to the f's with the g's, f inverse of x is the same as g of x. Those two things are the same. So we could be finding g prime of x. Here, this would be g of x. So we want to find f inverse prime of 8. So we're going to plug 8 in for the x. F prime, f inverse at 8. All right, so we need to find f inverse at 8. So this means that we want to find the x value when the y value is 8. So that's actually right here. So this is where we would flip these and say, all right, If f inverse is 8, then my result should be 2. So this is going to be 1 over f prime at 2. All right, well, we don't know f prime. We got f. But we can take the derivative here. So we got some power rules to do. So that's going to be 15x squared minus 18. We want to plug in 2. So f prime of 2 is 15 times 2 squared minus 18. So that's going to be 4 times 15 is 60 minus 18 is 42. So we get 1 over 42. And there we go. So that's going to be C. So that's what we got for that one. Again, I'll let you think about who Becca's nemesis is. Good luck. All right, question 6. Becca has some pencils X and some pens Y. The number is modeled by the equation 7x to the sixth minus 3xy equals 3,719,574. Find the rate of change of pens with respect to pencils, which in this case is dy dx, because the pens is the y and the pencils is the x. So that's not too bad. I see we got the x with the y. So this is probably an implicits question. So we're just going to jump in and take some derivatives. That one's kind of nice. Power rule, 42x to the fifth. This one's a little trickier because we've got the x times the y. So it's a sneaky product rule in here. So first, times the derivative of the second, which is dy dx, plus the second, that's y, times the derivative of the first. Derivative of minus 3x is minus 3. Derivative of this last piece, derivative of any number is just 0. All right. Next step, after we take all the derivatives, we need to get all the not dy dx's on one side, all the dy dx's on the other side. Probably going to be the easiest here to go ahead and just move this dy dx over to the other side. So let's just add 3x dy dx plus 3x dy dx. So we get 42x to the fifth minus 3y equals 3x dy dx. We can divide both sides by 3x, because that's the next step, is to GCF. It's just 3x. Then we divide to get dy dx by itself. And so we have our final answer. So I didn't fix this on this document. I did fix it on all of the tests, though, because this one on the tests, we fixed a negative and plus. And so that's what we're going to get for this one. So it's going to be D. So that's what we got for number 6. Again, I'll leave it up to you to find out how many pencils and pens she actually has. Good luck. Finally, we got 7. Becca loves pure math. Let b of x equal e to the x. Find b prime of x. Well, the derivative of e to the x is e to the x. So it's a. So that's what we had for that one. So that's it. That's the entire test.